of life. Okay, before I tell you the secret, I want you to know the sky is not going to open up and the light come in here. It's not such a big secret. Like a backbone, you can twist and flex and change the shape. So I will show you two shapes and ask you which shape is more stable, 1 or 2. And you can't answer the question because I leave out one fact. Okay, the yellow pipe are both negatively charged. 1, or this is 2. 1, which one? This one. Yeah, because the two negative charges, they repel each other. Okay, now the secret. There's a protein, and then there's something called a signal. The signal can be a chemical, like a drug, a hormone, a growth factor. Or a signal can be a vibrational wave. But I'll use the chemical one because you can see it. Now here's what this is negative, the yellow, okay? And this is positive charge, but more positive charge than this has negative charge. Okay? This comes like this. And when it gets near the protein, it will bind. What's the charge at this end? Yeah, and the charge here? Is this more stable or is this one more stable? What did it do? It changed shape? It moves. Movement is where life comes from. When proteins change shape, they create behavior. Now, if the signal comes off, what does the protein do? It moves back. So that you are made out of proteins, that gives you the structure, but the movement is the protein plus the signal. So if you are dead and you still have your protein body, what's missing? The signal. Okay, so in this protein gears, and each protein is like a lock, and the signal is like a key. And there's a different signal for different protein. When the signal moves and binds to the protein, behavior. When the signal is not there, no behavior. If you want the behavior to go again, what do you have to do? Under signal. Another signal, and then protein goes again. Your body will move when the signals come, will stop when the signals are not there. So these are, again, the 3 different proteins, and these are actual molecular studies of how the protein moves. With signal 1, with signal 2, signal 3. And this is the behavior of protein. Now, in medicine, the signals are always indicated to be physical chemical because medicine is Newtonian. So all signals must be matter. Recently, physicists are looking at protein movement. And this is a paper in the journal Nature. And these 2 authors, Popfristic and Goodman, were studying how proteins move, the behavior. And they wanted to predict the movement. So like Newton, when he predicted the movement of the planet, they used Newtonian physics, a Newtonian equation, to predict the movement. It didn't work. And this is a review of this paper. And this chemist, physical chemist, writes, the most pressing question raised by Popfristic and Goodman, when will chemistry textbooks begin to serve as aids rather than barriers to this enriched quantum mechanical perspective on how molecular turnstiles move? because when they used quantum physics to study the movement, they were able to accurately predict the movement. So the most important conclusion is the subtitle of the article. What are the forces that control the twisting and folding of molecules into complex shapes? Don't look for the answers in your organic chemistry textbook. The reason why this is important is that medicine is based on organic chemistry, and the answers to how life works are not in the book. In a more recent one, this concept of materialism, matter only, false. Okay, this is a more recent paper just a few months ago, and how they control biological functions. They were studying protein movement, and what they showed was this. It acted as a quantum mechanical machine. And if they shine a light on the protein, when the waves were in phase, the protein was active. And when they shine a light and the waves are out of phase, it shut off the protein. So it says, for a quantum mechanical object, one can arrange interference of several paths to create constructive interference that selects one state and destructive interference that blocks the other. Proteins respond to good vibes and bad vibes. So this is a picture of the light pulse that they shine on the protein to make it active or to shut it off. So our belief that we use today in medicine of chemical control is incorrect because the proteins respond to the vibration. So now you have enough information to know how life works. You are made out of protein. The signal, where does the signal come from? Field. Yeah. Right. And so the field is the signal. Medicine talks about molecules, but then physics talk about energy control. So the energy in your body that controls the protein is a vital force. So the new science brings back the old story of vital forces controlling life. So when a signal binds to a protein, what happens to the protein? It moves. It makes behavior. Okay? Now, if you are healthy, your behavior is good. But if you have a dis-ease, the behavior is not right. Question: what can cause disease? There's only two things. Either the protein is bad or the signal is bad. Now, look. People with bad proteins got them from birth defects, because if you were born with defective genes and the genes make the protein, then the protein is defective. But less than 5% of the population has birth defects. That means 95% of the people should have a healthy, happy existence. But if you were one of the healthy people and now you are sick, what would cause the problem? All right. There are only 3 ways to mess up the signal. 1, trauma. So if I fall off the stage and wrench my back, the signal is interfered with. Number 2, toxins. If the chemistry is not good inside the body, the signal cannot be passed through bad chemicals. Both of these interfere with the propagation of the signal. But the third one is thought, the mind. There is nothing wrong with the body. It's just sending the wrong signal at the wrong time. So if you change your thought and your mind, you can change the biology. And the mind is the primary cause of illness on our planet today. Okay, so now, I will now go and say the brain is is what controls the signals. So I will now show you how the brain of the cell works, because it's the same mechanism that the human brain uses to control our own life. So where is the brain? What controls the cell? Brain. Where is the brain? They know.
Yeah, they read your book.
The membrane. Now you might say, I said before that you and the cell are the same. So you might say, am I saying that your skin is the brain? Yes.
Ja.
Yeah.
Ja.
Yeah. In embryology, the sperm and the egg come together to make a zygote. And then the cell divides and makes a ball of cells called the blastula. And then the cells form three concentric layers. The outer layer is called ectoderm, the middle one is called mesoderm, and the inner one is endoderm. Each layer gives rise to specific tissues and organs. The ectoderm gives rise to two things. The outer layer, ectoderm, forms skin and the central nervous system. So like the cell, your skin is the brain. Well, I will show you now how it works. Inside the cell are the protein pathways. And the outside of the cell is the skin or the membrane. The signal comes from the environment and goes through the membrane to go to the gears. So the membrane controls if the signal comes in. Okay? The signal comes from the environment, the protein creates the behavior, and the membrane is a switch. Okay? This is like the other slide. Signal plus protein. Do they know what goes over here? Behavior. Now, I'm going to show the signal comes from the environment and hits the switch. Then the switch sends a signal into the cell to the protein to make behavior. So the switch controls the signal coming in. There are over 100,000 switches on the cell at any time, but all switches are about the same. It does two things. One, it reads the primary signal, and then the switch 2 sends a secondary signal into the protein. So there are two parts to the switch. In the skin are receptor proteins, and receptor means receiver. Okay, do you have receptors?
Habt ihr
in your body? Name the big ones.
The eyes,
no.
Nose, ears, mouth.
Okay, what's the point? All of your receptors are built into the skin. And these receptors read the signals from the environment. So it's just the same as a cell. This is a simple, like eye or ear or nose. The receptor has an antenna, responds to the vibration signals from the environment. What happens when a signal binds to a protein? What happens to the protein? The protein moves. So there's two states to a protein. Before the signal and after the signals, two different shapes. When the signal is active, it connects this one to this protein to this protein. And this protein, the effector, makes an effect. And it sends a signal into the cell to control the proteins. So the primary signal is picked up by the receptor. Then the receptor connects to the processor protein.